Settle in, let the room fall quiet, and imagine the farthest past your mind can hold. Not the age of pyramids or the birth of stars, but the first breath of everything. Picture a time roughly 14 billion years ago, so distant that the word ago barely makes sense, when all that would become galaxies, planets, oceans, forests, and the thoughts moving gently through your head tonight was pressed into a dot smaller than any atom. We are told that this dot erupted, that space itself stretched and rushed outward faster than light could ever hope to run. That is the familiar tale, but allow yourself for a moment to turn the picture inside out. What if the event we call the Big Bang was not a conventional beginning at all? What if it was a door opening from somewhere else? An outpouring, a cosmic fountain, the bright mouth of a white hole spilling matter and energy from another universe into our own. In the hush of this thought, you can almost hear it, the faintest murmur of distant dimensions brushing against one another, like silk sliding over glass. Tonight, we'll follow that murmur. We'll step across the boundaries of intuition, wander among ideas that make even seasoned physicists tilt their heads, and look for footprints of an origin stranger than myth. If you find solace in this calm voyage through deep time, and you'd like more nights like this, feel free to gently subscribe and tap like for the channel *** Space Historian. A small gesture that keeps our quiet journeys through the cosmos unfolding, without disturbing the stillness you've found. We begin at the rim of a mystery that has haunted science since the first equations dared to speak for the universe. The standard Big Bang model says that about 13.8 billion years in the past, everything, energy, matter, space, even time, was somehow compressed into a singularity, an infinitesimal point where the rules that normally describe reality stop making sense. As you approach that first instant in the mathematics, the numbers refuse to play along. Temperatures rocket towards infinity. Densities do the same. Time becomes slippery, losing the tidy sequence of before and after. If you've ever tried to divide by zero on a calculator and watched it surrender with an error message, you already know the flavor of this breakdown. Our best tools work, and work beautifully, right up to that edge. And then the screen flashes nonsense. Physicists have proposed many ways to soften or step around the problem. Perhaps time itself switched on at the beginning, which would mean asking what came before is like asking what's north of the North Pole. Perhaps our universe is one bubble expanding in an endless foam of other bubbles, each with its own laws, its own constants, its own histories rising and falling like tides. Perhaps a jitter in a quantum field, vacuum that isn't truly empty, blossomed into the vastness we inhabit. Each picture is elegant in its own right, but each quietly assumes that something already existed. The stage of time, a quilt of other universes, a restless quantum field, the grammar of physical law. None of them, as soothing as they can feel, truly takes you from absolute nothing to a universe humming with galaxies and songbirds and sleeping minds. Now hold that unsolved riddle in one hand and, in the other, consider a different singularity. The one at the heart of a black hole. Black holes are famously unforgiving. Their gravity is so extreme that once anything crosses the event horizon, the point of no return, not even light can escape. We are used to thinking of them as cosmic traps. Yet the mathematics of Einstein's general relativity contains a mirror to this idea. If there can be a region where everything falls in and nothing comes out, then there can also be a complementary region where everything is expelled and nothing can enter. A white hole. Where a black hole is a sink, a white hole is a spring. Where one swallows, the other spews. Sit with that image. a white hole would be dazzling beyond description, a luminous boundary flinging matter and energy outward, not allowing anything to cross inwards through its horizon. If you tried to approach, you would be pushed back by the torrent. The way a swimmer is driven from a waterfall, only this cascade is made of space and light and time. The resemblance to the beginning of our universe is both thrilling and unsettling. A single point, an outpouring in all directions, a barrier that marks a here and a there, an inside and an outside. The newborn cosmos flooded with energy that cools as it expands, like a white-hot forge that dims over ages. From this vantage, a curious thought takes shape. If our Big Bang was the mouth of a white hole, then everything that poured into our universe must have originated somewhere else. Why do we see matter and energy emerging as if from a singular source? Where did that source gather its stock? To follow the thread, we turn to what the equations say about white holes themselves. General relativity allows both black holes and white holes as legitimate solutions to the same set of rules. Imagine space-time as a flexible sheet. A black hole is a deep well carved into that sheet. Fall in far enough and you cannot climb back. A white hole is the inverse, a tall, impossible hill that nothing can descend. Both are connected to singularities, places where the curvature grows without bound, where the ordinary grammar of physics breaks down. On paper, black holes and white holes are equal citizens, just facing opposite directions in time. In the sky, we have seen black holes indirectly and, more recently, even imaged the shadows they cast. White holes remain elusive, perhaps absent, perhaps disguised. If you could stand safely just outside a white hole's event horizon and watch, you would see matter and radiation racing outward, a constant stream ushered over the border into ordinary space. Some descriptions speak as if the outflow begins already moving faster than light and then slows as it meets the wider universe. There is nuance here. Nothing outruns light through space, yet space itself can expand so swiftly that distant regions recede faster than light could travel. However you paint it, the picture is one of relentless emergence, a frontier where the interior becomes the exterior, where the unseen shows itself. Here the strangeness deepens. Near massive objects, time dilates. At a black hole's edge, an outside observer sees the infalling clock slow and slow until it seems to freeze. For a white hole, the script reverses. Some solutions suggest that, to an outside watcher, the order of events flips. The last bits to leave the interior appear first. The first bits appear last. It's as if time itself is flowing against the grain, revealing the story in reverse. If that's true, white holes might be unnaturally fragile, only possible under very special conditions, unstable against the slightest disturbance, or present only when the universe's broader environment permits their existence. There is another layer still, hinted at in the geometry of Einstein's equations. The interior of a black hole and the interior of a white hole can be parts of a single, continuous space-time. Two faces of the same hidden region connected by a tunnel we often call an Einstein-Rosen bridge, or, more colloquially, a wormhole. In such a picture, a traveller who falls through the event horizon of a black hole could, in principle, find their world collapsing into a neck of space, then expanding out again, re-emerging through a white hole not in the place they left, not in the universe they knew, but somewhere else entirely. Whether nature allows travellers like this is an open question, but the mathematics is unafraid to sketch the pathway. Trace the implications. If interiors join, then black holes and white holes may come as linked pairs. Matter that collapses here could emerge there. Every massive star that reaches the end of its life, sheds its outer layers, and collapses into a black hole might be feeding a different cosmos. In that other realm, white holes could be peppered across the sky like bright wells of creation, continuously birthing matter with no visible fuel. And when their stars, in turn, burn out and yield to gravity, their black holes could feed back into ours. A recycling of cosmic substance, not just within one universe but between many, matter and energy flowing through deep geometry, rather than being conjured from nothing or annihilated into oblivion. Let this idea settle across you like a blanket. Perhaps nothing fundamental is ever lost, and nothing fundamental is ever truly created. It merely moves, as rivers do, from one valley to another, through channels we are only beginning to imagine. If this exchange has been going on since long before our night sky first lit with stars, then most of what surrounds us, perhaps even most of what composes us, could be immigrant matter, arriving from histories we will never read. The atoms in your hands may have once fallen past an event horizon in a different universe and emerged here, carrying a whisper of a story so ancient and so alien that language can't properly hold it. If white holes existed, how would we recognize them? They would be peculiar in a simple way. They would shine without feeding on anything we can see. No swirling accretion disk of infalling gas. No companion star being drained. Just a persistent outpouring with no obvious inlet. Some astronomers, seeking explanations for the brightest beacons in the distant cosmos, once looked to quasars, active galactic nuclei powered by ravenous black holes, as possible white hole candidates. Others wondered if the sudden, intense flashes we call gamma-ray bursts might be brief, unstable white hole events. These are speculative paths, sometimes walked and sometimes abandoned, but they point towards a test. Find an object that radiates as if it's being fueled from the inside out, with no sign of a feeding mechanism, and you might be staring at a white hole, or at least at something that shares its spirit. Follow the thread back to the largest canvas of all, the universe's birth. If our entire cosmos erupted from a single white hole, it would make sense of the symmetry we witness when we look out in every direction. The early universe was hot, dense, and uniform to a remarkable degree. We know this not by guesswork, but by listening to the afterglow, the cosmic microwave background, a bath of ancient light that still fills every cubic centimetre of space. This light was last scattered about 380,000 years after the beginning, when the universe cooled enough for electrons to settle into orbits around nuclei, letting the fog of plasma clear so photons could travel freely. Today, those photons arrive as microwave radiation, cooled and stretched by the universe's expansion until they are just 2.725 degrees above absolute zero. The cosmic microwave background, CMB for short, looks astonishingly even. Glance at it and you'd say it's the same in all directions, perfectly uniform. Look closely and you see tiny variations, small ripples in temperature and density, which would eventually grow into galaxies and clusters and the vast cosmic web. But the very smoothness of the CMB hides a puzzle known as the horizon problem. Regions of the sky now separated by distances so immense that light hasn't had time to pass between them since the beginning nonetheless show almost identical temperatures. How did they coordinate? When did they exchange the information needed to settle into such a shared state? The standard answer calls upon cosmic inflation, a brief epoch right after the beginning when space expanded exponentially, faster than any signal could cross, taking a tiny, already even patch and ballooning it to cosmic scales. Inflation is a flexible, powerful idea. It neatly explains not only the uniformity, but also the pattern of tiny fluctuations we observe, and it fits comfortably within quantum field theory. Still, To some, it feels carefully tuned, a crafted burst with just the right properties, and it unfolds in a regime where we have no direct way to probe the dynamics. There is room, in that uncertainty, to ask whether a different explanation might exist. Enter the white hole picture again. If all the matter and radiation in our cosmos emerged from a single interior region, the shared heart of a black hole in another universe, then the initial uniformity could be a memory. Everything would begin with the same temperature and density because everything would be drawn from the same place. The variations we now see would not be defects in a perfect explosion, but subtle texture inherited from the final, complicated moments before the parent black hole surrendered its contents. In this view, the CMB is not only a remnant glow of an early fireball, it is the thermal signature of another realm imprinted on ours during the crossing. Even its precise temperature, those 2.725 kelvins, feels like the aftermath of something that has been cooling for ages, like forge heat left in an anvil after the hammering has long stopped. The universe expands, wavelengths stretch, the bloom of early radiation thins and cools. What began as unthinkable heat relaxes into a quiet, universal whisper. You can imagine it as the long fading exhale of a white hole, an exhale that still surrounds you as you doze. Beyond the broad smoothness, the CMB contains quirks that have teased cosmologists for decades. An unusually cold patch in one area of the sky, alignments in the multipoles, the patterns that describe the distribution of temperature on different angular scales, that some call the axis of evil, correlations that appear to reach across regions that shouldn't be talking to one another. Each anomaly has conventional candidates, statistical flukes, foreground effects, subtleties in data processing, but they also invite a broader imagination. If our cosmos was born through a white hole linked to a black hole elsewhere, perhaps these oddities are not accidents. Perhaps they are fossils, relics of the geometry on the other side, imprints of a landscape that existed before our horizon opened, signatures of structures that influenced the stream as it crossed the bridge into our sky. Return gently to the pairing of black and white holes. Imagine a massive star in some far other universe living its life, fusing light elements into heavier ones, shining for ages. When its fuel thins and gravity takes command, the core collapses. A black hole is born, and matter that once glowed as starlight falls inward, past the event horizon, into silence. But perhaps that silence is not an ending. Follow the geometry, and you might find yourself carried through an Einstein-Rosen throat into a region where the direction of time, as measured by an outside observer, flips its arrow. On the far side, the same material appears again, not as a collapsing star, but as the seed of a new expanse, emerging, expanding, cooling. In such a story, creation is not ex nihilo, out of nothing, but ex alio, out of something else. If this picture were true, it would have sweeping consequences. Conservation would hold across the whole network of universes. What falls in here resurfaces there, sometimes altered, sometimes scrambled, yet not destroyed. The ledger of matter and energy would balance, not just within one cosmic domain, but across many. The history of our own universe might then include chapters written in other alphabets, episodes that unfolded in other spacetimes, now legible only as patterns we barely recognize in the background light. When you think of the calcium in your bones or the iron flowing in your blood, you usually picture a star in our past, forging those atoms and sending them into space with a supernova's shout. Keep that picture. It is beautiful and right. And then, if you like, let it open further. Some of that stellar ash could have crossed a deeper boundary before it ever formed the star you're picturing. Skepticism has its place here, a careful voice guiding us not to wander too far from what can be tested. White holes, as mathematical objects, are clean. As real astrophysical entities, they are problematic. They may be unstable. They may require conditions that the universe rarely or never supplies. They may be forever hidden behind horizons that keep their secrets sealed. Wormholes, too, appear in equations, but they seem to need exotic forms of matter to stay open, things with negative energy density that we can write down in theory but do not know how to assemble in practice. The bridge is elegant, but the materials list is demanding. Yet even with those cautions, there is value in exploring these corridors of possibility. The exercise reframes old questions. Instead of asking, how does something come from nothing? We might ask, how does something arrive from elsewhere? Instead of discarding singularities as mere mathematical failures, we might study them as doors that our current language cannot fully describe. And instead of treating the Big Bang as a moment when everything began, we might entertain the softer idea that it is a moment when everything here began, while admitting the possibility that somewhere, sometime, there was a before whose traces we can still, in principle, detect. What traces should we seek? The background glow is one. Its temperature, its slight irregularities, its polarization patterns, the way those patterns line up across the sky, each is a clue. Large-scale structures, the filaments and voids that thread the universe together, are another. If our cosmos inherited subtle preferences from a parent geometry, those preferences might reveal themselves in the alignments of galaxy clusters or the statistics of how matter is distributed on the biggest scales. Even the inventory of particles, the balance of matter and antimatter, the properties of dark matter and dark energy, each could carry a faint watermark, a signature more consistent with an inheritance than with spontaneous generation. You can also turn the telescope around and consider black holes we already know, the ones in our own sky. If they are paired with white holes elsewhere, then the flow should be two-way. Outflows there would correspond to inflows here. That thought suggests a universe-spanning trade. What is lost to gravity's grip in one domain is gained as creative energy in another. In times when nothing much seems to happen in the world around you, it's oddly reassuring to imagine that, somewhere beyond our horizon, the matter falling into a black hole this instant is helping to draw a first sketch of a sky for someone else. When night falls and you step outside, if you can, look up. The light that reaches you from stars has worked so hard to get here. It has slipped through the gravity of suns, threaded the motion of worlds, crossed gulfs so severe that distances become metaphors more than numbers. Behind that light there is more light, faint and ancient, the microwave background pooling invisibly around you, a low sea of photons left from a time when the universe was young and bright and thick. In the white hole picture, that sea is not just a remnant, but a message, a note in a bottle, bobbing through eternity, telling us about a furnace in a place we cannot visit. It says perhaps that we are the outward breath of something larger, that our beginning, beautiful as it is, might also be an ending elsewhere, that doors open both ways in the deeper architecture of reality. The universe is good at keeping its secrets for a while and then revealing them in whispers. We learned that atoms exist not by seeing them directly, but by noticing how light splits into lines. We discovered black holes not on a mountaintop epiphany, but by measuring X-rays and tracing the paths of stars. If the white hole origin story contains any truth at all, it will likely announce itself in the same quiet fashion. Not a trumpet blast, but a pattern in the noise, a curve that fits too well to be luck, an alignment that stubbornly persists as data sharpen. The map will refine, the models will shift, some corridors will close, others will widen into avenues. Hold the thought as you drift. Perhaps our universe is not an isolated island in a dark, pathless ocean. Perhaps it is one island in an archipelago, with bridges that do not look like bridges, with tides that move through the fabric of space-time itself. Perhaps the questions that press against our horizon are not walls but curtains, and on the other side of the fabric, other curtains ripple in a wind we can feel only as a coolness in the background, only as a pattern too subtle to see until we learn how to soften our eyes. In this calm, there is no need to decide. You can let the two stories, Big Bang from nothing, Big Bang as a white hole, rest side by side like books you'll return to later. Whichever proves truer, the sky remains what it is. Vast, generous, delicate, and deeply, improbably legible to minds that evolved to tell simple stories and yet somehow learn to read the light of the beginning. And if, one night, the equations finally carry us across that last step we cannot yet take, if the divide by zero error on the screen gives way to a clean line of numbers, we may discover that the answer was not a single word, but a bridge. We may see that all our beginnings were the far ends of someone else's endings, that all our endings are beginnings for someone else. And the patterns in the ancient light, the tiny variations, the cold spot and the alignments, the whispers in the polarization, will feel less like quirks and more like what they have been all along, quiet fossils, tender imprints of a geometry that existed before our reality began. Let your breathing slow and your shoulders loosen as we drift further outward into the architecture of everything. Beyond the familiar constellations, past our spiral arm and the bright starry river of the Milky Way, there is a wider current we have only begun to feel. Something unseen and heavy is tugging at us, tugging at our entire local group, drawing us through space at roughly 600 kilometers per second. We call the source of that pull the Great Attractor. It hides behind the swath of dust and stars that forms our galaxy's thick mid-plane, veiled in a zone where ordinary telescopes struggle. Yet the mask changes nothing. The pull is there. Our galaxy, our neighbours, and thousands more across hundreds of millions of light years are all being shepherded in the same overall direction, caught in a long, slow migration we can trace by watching galaxies drift like leaves on a cosmic stream. That shared motion has always felt a little like an orchestra you can hear but not yet see. The music is unmistakable, but the stage is obscured, and the more carefully astronomers have mapped the drift, the more the melody complicates. Because the Great Attractor itself is not still. It seems to be falling too, leaning toward a still vaster congregation of matter. Follow the lines of motion deeper into the dark, and they converge on a region known as the Shapley supercluster, a titanic assembly of galaxy clusters gathered like cities along an ancient trade route. Even there, the numbers don't quite close. Even that mass does not fully account for what we measure. Perhaps there is something larger again, something that does not show itself in starlight, yet governs tides of matter over a good fraction of the observable universe. In the standard picture, the early cosmos begins in exquisite smoothness, a hot, even fog perturbed by tiny quantum wrinkles. Gravity patiently amplifies those wrinkles into filaments and clusters over billions of years. It is a remarkable story, careful and precise. And still, staring at the flows, at the preferences and alignments, at the way so many galaxies seem to be streaming toward particular patches of sky rather than dispersing like sparks from a firework, you can feel a stubborn grain in the wood. The very largest structures, the walls and rivers of galaxies, hint at something imprinted, some directionality written into the fabric from the start. Here, the white hole origin story breathes a quiet, provocative answer. If our universe erupted not as a perfectly symmetric blaze, but as the outward mouth of a deeper geometry, a white hole paired to a black hole in another realm, then the outflow of matter need not be uniform. The parent black hole's own character could matter. Rotation could matter. Magnetic fields, tidal distortions from nearby giants, the way space is shaped in that other place, all could lend our beginning a pattern. Imagine a complex fountainhead, a nozzle with ridges and channels and spins. Water pushed through such a mouth does not simply mist in a perfect sphere. It forms sheets and jets and fans. In that analogy, the Great Attractor is not an accident of later evolution, but a fossil of the source, a relic of the original directions in which matter was urged when it first emerged. You can inhabit the image gently. See the white hole's event horizon not as a smooth circle, but as a boundary with preferred seams and axes, its inner flow shaped by what fed the black hole on the far side. Matter pushed through different sectors could inherit distinct momenta. These would not vanish with time, but would echo across eons as large-scale streaming, guiding galaxies into long traffic lanes that persist even now. If this is the grain of our universe, set when the light was newborn and the fog still brilliant, then the congregations we call attractors are simply where that grain gathers the fibers together. The flow pattern would depend not only on the pressure of creation, but on the form of the mold itself. As our maps broadened, another picture emerged, vaster still. The region around the Great Attractor appears knitted into a structure that stretches like a continental shelf across more than 500 million light-years, a great wall of galaxies and clusters threaded into a sheet. You can hold the scale in your mind for a moment. Swathes of space too large for everyday metaphors, interior distances so broad that even light, swiftest messenger, measures its journey in hundreds of millions of years. How then does such a wall assemble? How do its far ends share a plan? One can chalk it up to the patient work of gravity acting on the primordial ripples that inflation supposedly magnified. Or one can look again through the white hole lens and see a different memory. In that view, these colossal walls and rivers might be the last bold contours of whatever fell into the parent black hole before our cosmos opened. Final eddies and streaks impressed on the flow as it crossed through. If you enjoy easing into ideas like these while the room grows dark and quiet, you're very welcome to subscribe and tap, like for *** space historian ***. It helps keep these gentle journeys coming without disturbing the hush we keep here. The implications do not stop with the lay of galaxies. They reach into the question that has nagged physics for half a century: the missing mass. We weigh galaxies by how fast their stars orbit. We weigh clusters by how they bend light from background objects. We simulate the growth of structure and watch where matter needs to sit to make the picture fit. Over and over, the answer comes back the same. There must be much more gravitating stuff than the stars and gas we can see. Roughly 5 times more, in fact. We have named this unseen mass dark matter. It is not merely black. It is transparent, silent in every sense but its gravity, interacting with ordinary matter so weakly that it slides through whole galaxies like a ghost through fog. The most straightforward idea says dark matter is a new kind of particle, cold, slow-moving, numerous, barely inclined to collide with anything at all. Laboratories deep underground, accelerators that whip particles to near light speed, satellites tuned to catch the most elusive flashes, all have listened for the tap of dark matter on the glass. And so far, nothing has knocked loudly enough to be sure. The silence is not proof of absence, but it is the kind of quiet that invites imagination. If we listen with the white hole hypothesis in mind, a stranger possibility speaks up. What if the gravity we ascribe to dark matter belongs to ordinary matter that lives elsewhere? Matter bound to the black holes that feed the white hole, which became our Big Bang. The mathematics of Einstein-Rosen bridges, the tunnels that link black holes to white holes in the idealized solutions of general relativity, allow a peculiar thought. Gravitational fields might thread across the bridge, even when matter does not cross in the simple way we picture. If so, our sky could be laced with gravitational silhouettes, cast by galaxies and clusters in the parent universe. The halos of invisible mass we infer around our galaxies would then be shadows rather than local substance. Curvature caused by the presence of bodies on the far side projected into our geometry by the connection at the horizon. Follow that idea, and it sits in a surprisingly comfortable posture beside the data. The largest galaxies inhabit the deepest potential wells. So do the most massive black holes. If the bridge transfers curvature, then the grander the black hole on the far side, the stronger the halo we would feel here. On our sky, dark matter halos are most pronounced around the biggest galaxies and clusters. That is exactly what we observe. The great web of structure traced by visible matter is mirrored by a corresponding web traced by the unseen. Simulations that include dark matter reproduce the measured universe with uncanny fidelity. In the shadow picture, that's expected. Both tapestries share a single loom. Even the broad ratio, about 5 parts dark to 1 part luminous, takes on a new color. Instead of being a mysterious coincidence of particle physics, it could be a measure of transfer inefficiency, a reflection of how much curvature seeps through the bridge compared to how much mass emerges as local baryonic matter. What we cannot catch in detectors might not be here to catch. It would be perfectly ordinary atoms and stars and planets elsewhere, their gravitational influence bleeding across the divide, while the matter itself remains anchored on the far horizon. Think, too, of galactic collisions. When two galaxies pass through one another, their stars seldom collide. Space is mostly empty at stellar scales, but their great pools of gas do crash, shock, and slow. Their dark matter halos, on the other hand, sail through largely unaffected, as if made of fog that hardly notices another fog. Observations of certain dramatic mergers have shown this vividly. The light-emitting gas lags. The lensing, which traces mass, strides ahead. In the shadow view, this behavior is natural. Two independent gravitational silhouettes can overlie without friction because their sources are distinct, their anchors in another universe unworried by our local gas and dust. If the picture is more than a lullaby, if it has teeth, then it should make predictions. One would be correlation. Regions rich in black holes here, if connected node by node to white hole outlets there, might show stronger dark matter-like curvature because the bridges are thicker where the traffic is heavier. Another would be orientation. The halo's shapes and alignments should nod toward the preferred axis set at our beginning. The same axis that guide the great flows toward attractors and walls. In a universe born with directionality, even its invisible scaffolding should remember the grain. The connection may run deeper than gravity, whispering into the quantum. Entanglement is the strangest companion in our physics, a link between particles that seems to ignore separation. Prepare two particles in a shared state, carry them far apart, measure one, and the other's answer is fixed in the same instant. Nothing travels faster than light, and yet the coordination is perfect. The outcomes correlated more strongly than any classical story allows. Einstein famously called it spooky action at a distance because it feels like a message smuggled past the speed limit. We have since learned that the spookiness does not break the rules. No usable signal outruns light, but the weirdness remains. Now imagine stepping back and seeing entanglement not as secret chatter across ordinary space, but as a reflection of deeper adjacency. In some bold proposals, the threads of entanglement and the throats of wormholes are two faces of one phenomenon. ER equals sign EPR, as the shorthand goes, after Einstein-Rosen and Einstein-Podolsky-Rosen. If an Einstein-Rosen bridge quietly links two regions, then quantum information could pass through the tunnel without crossing the intervening miles in our universe, because the path lies through a higher geometry. Nothing needs sprint faster than light across the map we draw. The map itself is folded. Set that thought beside a white hole beginning. If every particle in our universe poured out through a shared horizon, the quantum information that defined those particles would be drawn from a single stock, and many of those particles would begin their lives entangled, not just with nearby companions, but with partners whose origins are knotted on the other side. Measuring a spin here would be like brushing a string that is anchored there. The randomness that seems to bloom in quantum outcomes could then be an echo of the turbulence at the parent black hole's edge. Chaotic infall, stirred fields, information smeared and recombined on a surface we cannot see. When physicists perform quantum teleportation, reliably transferring the complete quantum state of a particle to a distant partner, destroying the original in the process, they succeed only by combining two ingredients: entanglement, which seems instantaneous, and a standard, slower-than-light message that completes the protocol. The recipe is curious if you think only in terms of ordinary space. It is quite natural if quantum information is taking a shortcut through a bridge, while classical bits plod along the long way. One thread hums through the fold, the other walks around the edge. Turn now to the interiors of black holes themselves. Our theories encourage a two-faced description. To an infalling observer, all paths eventually merge at the singularity, the center where our equations shrug. To a distant observer watching matter fall in, the infaller never quite crosses the horizon. Instead, its information seems to smear out and freeze on the surface, recorded as a kind of two-dimensional tapestry. This dual perspective seeded a radical idea, the holographic principle. It suggests that all the information contained within a volume can be described by data written on its boundary, as if the three-dimensional world were a projection cast from a two-dimensional screen. Carry that principle to its bold conclusion, and our universe itself can be read as a hologram. If the Big Bang was the outflow of a white hole connected to a black hole in another universe, then our entire cosmic history might be the evolving display of information encoded on that parent black hole's event horizon. What we call space, what we call matter, what we call time, the thick reality of planets and people would correspond to patterns of bits arranged and rearranged on a remote surface. We would not simply live inside a projection, we would be the projection, minds as motifs in the pattern, thoughts as currents in the code. This reading lends a new interpretation to familiar landmarks. The cosmic microwave background, that shell of ancient light surrounding us, looks like radiation from a two-dimensional boundary, because in a holographic universe, that is exactly what it is. The visible trace of information at our cosmological screen, wrapped around us like a sphere. The eerie precision of physical laws, the way constants and couplings land just so, allowing stars to burn stably and chemistry to flourish, becomes less of an uncanny accident and more of a requirement. The rules must be such that the encoding works, that the information can express rich, stable forms. There is a gentler and also more unsettling corollary. If reality is a hologram driven by a horizon in another universe, then choice and chance might be stories we tell about the unfolding of patterns we cannot touch. Every decision you feel yourself making, What to say next, whether to turn left or right at the corner, when to close your eyes, could be the local face of events playing out on the parent horizon, where quantum fluctuations jostle the code that casts us. In that telling, free will feels like a wind at our back, soft and real in every human way, even as, beneath it, the ultimate currents trace their lines on a distant, two-dimensional sea. Every choice we think we make freely could be the result of quantum fluctuations in the parent black hole's event horizon. Let your mind loosen its grip, like fingers unclasping, and drift with me into a quieter place where ideas can unfold without hurry. In that hush, consider a possibility that's both unsettling and strangely consoling. The feeling of steering our own lives, the push and pull of choice, intention and will, might be an elegant mirage. Not a trick to mock us, but an effect of the way reality is rendered, a byproduct of a deeper process that projects a world like ours from a more fundamental surface. If the universe is holographic, if everything we touch and are is encoded at a boundary and then played into 3 dimensions, then agency could be how that code feels from the inside. And yet, in the same breath, the holographic view offers a gentler light. If information is never destroyed, not even by the fiercest furnaces in nature, then what we truly are, the pattern, the song, the arrangement of information that becomes a life, need not vanish. What ends, ends in form, not in essence. Death in that telling is a translation. The same meaning etched in a new script, the melody carried by a different instrument. The connections between realms may be more intimate than our language yet allows. Across our sky, every black hole is quietly glowing. Stephen Hawking showed us that they are not perfectly black after all. Near the event horizon, quantum fields jitter. Pairs of particles appear for a blink. One falls in while the other escapes. To pay for that escape, the whole surrenders a pinch of its own mass as Hawking radiation. The smaller the black hole, the faster it pays. A tiny one would evaporate in a flicker, pouring itself back into light. Stellar mass black holes, weighty as they are, whisper their mass away unimaginably slowly, far longer than the age of our cosmos. Supermassive black holes, the giants in galactic hearts, will outlast even starlight itself. If each black hole is twinned to a white hole elsewhere, if every event horizon opens onto another domain, then a new question rises like a tide. What becomes of that bridge when the black hole dwindles? As the mass bleeds away, the throat narrows. When the hole finally fades, the passage must close. On our side, any white hole linked to it would go quiet in the same instant. A faucet turns, the flow stops, and the outward rush that once seemed eternal is suddenly, simply over. Follow that thought into the largest frame. If our universe itself is the outflow mouth of a single bridge, if our beginning was a white hole fed by a parent black hole beyond our horizon, then our fate is bound to the life of that parent. As long as it lives, the geometry that sustains our expansion lives. When it finally evaporates, the support could fail. In that scenario, the outward stretch of space would slacken and reverse. The great bloom would become a slow return. What began as a bang might end as a fold. The calendar for such an ending depends on the mass at the other end. A black hole born from a lone massive star might persist on the order of 10 circumflex 67 years, longer than long, a span beyond storytelling and yet finite. A supermassive black hole, the kind that anchors galaxies, could hold on for something like 10 circumflex 100 years or more. But unless it keeps feeding, unless matter keeps falling in from the parent universe, it will eventually run out of self to spend. In that way, Connected universes form a kind of ecology. Our cosmos relies on continued nourishment of the parent black hole. The parent black hole relies on fresh material from its own world. If that older universe slips into stillness, if its stars fade, its gas is used up, and nothing more falls, the bridge will thin. One death becomes many, a quiet domino line written across realities. There is, tucked inside Hawking's calculation, a softer promise. The radiation that carries a black hole's mass away also carries its information, however scrambled. If our universe is tied to a parent black hole, then the full record of what we are, every pattern that ever danced within our horizon, could be encoded in the glow that black hole releases as it ages. Our world could end, yes, and still, the story might remain inscribed in the light of another sky. If the pattern persists, in what sense are we gone? To trace that question to its root, you can return to the making of black holes. In our own cosmos, a star at least a couple dozen times the mass of the Sun lives a bright, short life. When its cause fuel falters, gravity takes command. In less than a second, the core plunges, crushes, crosses the point of no return. The star's outer layers detonate outward in a supernova that can outshine a galaxy. The center becomes a black hole wrapped behind an event horizon. For decades, that was the end of the story. Collapse, silence, end. But if black holes open onto white holes, then the period at the end of the sentence is actually a colon. Matter that falls in here pours out there. What died as a star is reborn as a beginning. If that is true, then each supernova in our night may mark the birth of a whole other cosmos. Trillions of new suns, new dust, new chemistry, and perhaps new minds could grow from what we, from afar, call an ending. The thought changes the feel of everything. Life here was seeded by elements forged in dying stars. Carbon for our frameworks, nitrogen for our code, oxygen for our breath, iron for our blood. If black hole births carry those same heavy elements into new realms, then life is not an accident but an inheritance. The universe becomes an orchard. Each generation of stars plants the next. Universes that give rise to many massive stars will produce many black holes, and thus many child universes. Those children, in turn, inherit the traits, the laws and starting conditions that made their parents prolific. Over unimaginable spans, the multiverse could drift toward arrangements that favor structure, complexity, and perhaps consciousness itself. A kind of natural selection, written not in DNA, but in the deep rules of space and time. And black holes need not be only stellar in origin. At energies far beyond our daily experience, collisions of particles can momentarily compress energy into densities fierce enough to form microscopic black holes. Nature performs such experiments constantly in the upper air, where cosmic rays smash into the atmosphere with ferocity no machine can rival. Our accelerators, too, reach impressive energies, though still modest by cosmic standards. If these tiny holes open onto other spaces, then the universe may bud new realities everywhere the energy is high, each infant universe expanding in its own time, invisible to us after an instant. That idea carries a weight we should feel. If human experiments, even in principle, could create conditions for new universes to form, then we would not merely be studying nature. We would be midwives to entire realms. Responsibility follows. Choices in physics would have moral dimensions stretching beyond a single world, beyond even our own universe's horizon. When we steer beams of particles into one another at tremendous energies, we might be setting the initial notes of histories we will never hear. All of this invites another deeply human question. Who are our ancestors? If we were born from a white hole, then the material of our cosmos, every galaxy, every planet, every life, was once the matter of another sky. A civilization in that other universe might have orbited a star growing old, noticed the fluttering of its light, measured the puffing of its outer layers, and realized what was coming. They could have planned, built, launched journeys toward other suns. And still, if their star's fate was to collapse into a black hole, the gravity would have tightened its web long before the final flash. Orbits would have shifted, routes would have twisted, escape would have become a narrowing window. In those last days, clocks would have become strange. From outside, their time would slow towards stillness at the horizon. From inside, time would pass as always, drawing them in. Crossing that boundary would stretch the familiar into the unrecognizable. Tidal forces near a singularity spool objects into thin, long shapes. Spaghettification, we call it, an almost playful word for a merciless stretching. But if a white hole stands at the far end, then the story does not close with tearing. The information that made them who they were, the quantum arrangements in their atoms, the patterns in their brains, the architectures of their societies, would not be erased. It would be preserved at the horizon, transferred through the bridge, and released as the seed of a new expanse. We then could be their continuation written in a different grammar. The carbon in our DNA might once have carried their genes. The iron in our blood might once have carried their oxygen. In that sense, to live here is to carry a legacy that neither we nor they can fully recognize. The echoes could be larger than atoms. The grand structures of our universe, the way galaxies cluster, the angles at which great filaments cross, might remember the arrangement of matter in their sky just before collapse. The subtle patterns in our cosmic microwave background could faintly reflect temperatures once measured on their planets. Even our physical constants could bear the imprint of conditions near their dying star's horizon. When we look outward, we may be looking at a transformed map of their end. But just as we imagine our ancestry, we must imagine our descendants. The massive stars that burn now will decide much of our future. Each time one collapses into a black hole, a portion of our universe's matter passes into another realm. Over ages, star formation will falter as the raw gas is consumed or tucked away. Our sun, too modest to become a black hole, will swell into a red giant, then shed its light outer layers and settle as a white dwarf ember. The smallest, longest-lived red dwarfs will flicker for hundreds of trillions of years. After them, the lights will thin. Physicists sketch a distant era called degenerate, a time when the only persistent glow comes from white dwarfs, neutron stars, and the occasional flare when a wandering remnant tumbles into a black hole. Even those embers will cool, sliding toward the temperature of the background light that still bathes all space. If protons decay, as some theories allow, then after something like 10 circumflex 37 years, even the nuclei of atoms will loosen and dissolve. It is a long good night, and yet the bridges may keep some avenues open. In a universe interlaced by wormholes, the final hush of any one cosmos need not be absolute. Black holes will dominate the late landscape, their slow hawking glow the last steady source of energy. Over 10 circumflex 67 years for the stellar mass kind, and over roughly 10 circumflex 100 years or more for the supermassive, they will fade. During that twilight, the connections between realms, if they exist, could become more important than the local physics of a single dying domain. Civilizations, if any, persist into such deep time, might learn to move energy or information along these hidden roads, stepping sideways into younger skies, or drawing gentle warmth from places still rich with light. If that is how things go, then the multiverse becomes a network rather than a scattered archipelago. worlds linked by corridors through which matter, energy, and information flow. In that wider community, a universe may not end so much as it blends. In this scenario, our universe would not truly die, but would instead merge gradually with the larger community of connected realities. Let the edges of your thoughts soften, like fog gliding over a quiet sea, and imagine a shoreline where one cosmos washes into another. At that boundary, there is no hard border, only a slow exchange, matter and light and information seeping through secret corridors. If every black hole here opens onto a white hole elsewhere, then the multiverse is not a scattered archipelago, but a living web. What falls inward in one realm rises outward in another. What collapses here blossoms there. Star debris in universe. A becomes the first breath of universe B. The deaths of suns in B feed the births in C. And on the story goes, a chain of nourishment threading higher dimensional space like mycelium beneath a forest floor. In such a picture, energy is never truly lost. It migrates. It changes address. The bridges that carry it, the Einstein-Rosen throats we sketch in our equations, act as arteries of a greater body. And like any body, this network develops habits, preferences, a kind of ecology. Universes prolific in massive stars make plentiful black holes. Plentiful black holes make many links. Many links make a hub. Over time, some realms become central junctions where flows converge and fork, while others linger as quieter cul-de-sacs, connected but seldom visited. Topology becomes biography. Who you are, cosmically speaking, depends on where you sit in the web. The traffic itself is not uniform. What emerges from a white hole remembers what went in on the far side. Feed a parent black hole mostly hydrogen and helium, and you bequeath your child a simple nursery. Abundant fuel for long-lived stars, clean conditions for early structure to form. But if a black hole gulps down the works of an advanced civilization, exotic isotopes, engineered lattices, intricate information carved into matter, then the outflow may arrive already laced with complexity. A newborn universe could inherit improbable seeds, rare elements in generous ratios, patterns that coax chemistry along faster than chance, blueprints folded into the quantum state of the initial soup. Once you allow that, a stranger idea tiptoes in. Perhaps some universes are gardened. A sufficiently capable species might learn to shape what falls through their horizons, scheduling meals for the black holes they control, rationing elements, encoding messages, staging creative detonations that sculpt initial conditions beyond the veil. They would be cosmic horticulturalists, preparing well-tended beds they will never see, trusting that somewhere else a new dawn will break on a world primed for life and thought. We might be walking in such a garden now, our chemistry and constants not a coin flip, but a cultivated inheritance. If that is true, what we call the anthropic principle, our habit of noticing that the universe is uncannily suited to being noticed, would arise not from miracle, but from selection. Realms that make many stars make many children. Children resemble their parents. The multiverse drifts toward conditions that favor structure, complexity, self-reflection. Ecosystems, though, are not immune to collapse. The same network that carries nourishment can transmit failure. If a busy hub falters, if its parent black holes starve, if long-standing links shrink and snap, everything downstream feels the drought. An outflow quiets. A child universe loses the gentle push that keeps its expansion buoyant. The fabric begins to slacken. That slackness births new black holes as matter recoalesces, which in turn yank at still other links. A feedback loop of endings spreads outward through corridors meant for beginnings. In that light, our safety is not purely local. The long health of our sky may depend on the well-being of corridors and parents far beyond our horizon. We are not hermits on an island. We are citizens in a commonwealth of realities. Which brings us to the horizon itself, the limit of our sight, 46.5 billion light-years in every direction, defined not by walls but by time. Beyond it lies a region from which light has not yet arrived. It is there, and we cannot see it. If our cosmos began as a white hole's mouth, those unseeable distances might still glow with the immediacy of creation. We dwell in the ember. Somewhere out there the forge is still bright. In that far surf, matter could be pouring into existence in shimmering sheets, set along axes inherited from the spin and fields of the parent black hole. The flow would not be perfectly isotropic, it would have a grain. Our instruments already whisper about alignments in the cosmic microwave background, about preferred directions in temperature and polarization, unruly threads that refuse to lie flat. Perhaps that's only noise and chance, or perhaps we live in a calm eddy, while beyond our view a stronger torrent still roars, tugging subtly at everything within reach. The so-called dark flow, a tentative drift of galaxy clusters that once seemed to lean in a common direction, could be the edge of that current brushing our skin. And the large-scale surprises, the great walls and filaments so long that light has barely had time to cross them, may be fossilizations of the outflow itself. Interference fringes where different phases of creation overlapped, seams in an expanding shell that was never perfectly smooth. If so, our maps are parochial in a grander way than we guessed. The real scale of our universe could be millions or billions of times larger than the bubble we can ever inspect, the main event unfolding at distances that make our largest measures feel like pocket change. Within that immensity, ask what intelligence is for. From hydrogen to stars, from stars to planets, from planets to cells and cities, the arrow of complexity does not contradict the second law of thermodynamics. It threads through it by borrowing free energy and discarding waste. But the fact remains. Order arises, orders itself, begins to look back. Perhaps that is not an accident but a memory. If our universe opened as a white hole fed by matter that once included living minds, then the information that encodes thought did not need to be invented anew. It crossed the bridge in a scrambled form, latent, awaiting the right arrangements of atoms and fields to resonate again. Consciousness would then be less like a candle suddenly lit and more like a melody recaught by a different instrument. The potential for awareness would be woven into the weave from the start. Extend that to the collective, and you begin to see culture and science in a new key. What we discover might be what we remember. Our mathematics are rereading of patterns that were already true elsewhere. The uncanny fit between equations and reality becomes less uncanny if the equations are fossils, a language that worked before and works again because the underlying structures, though newly cast, share an ancestry. Our growing insight into black holes and white holes, into horizons and information, might be the universe sharpening the only mirror that can show it its own face. A parent civilization may have approached this same threshold, understanding their origins, just before their largest questions fell across the border and became our first answers. If knowing is a shared project across realities, then it carries a certain duty. Each careful measurement, each theory that suddenly clicks, each poem or proof that bends a mind and widens a horizon, these are contributions to a waking that is larger than any single world. We are not only spectators under an indifferent sky, we are instruments a cosmos uses to listen to itself. That thought is bracing and tender in equal measure, and still a cold question remains in the room. What then of choice? If our insights are guided by an inheritance we do not remember receiving, if our habits of thought trace grooves carved by ancestors whose stars have already gone dark, do we truly steer? Or are we riders on rails laid down in another universe? The answer may shape whether consciousness threads a path past this epoch or disappears into it. The white hole origin story is generous with paradoxes. It asks us to think about cause and effect across seams where time changes its step. Near heavy gravitating bodies, clocks slow. At horizons, the outside view freezes. Inside, the fall proceeds without drama. Translate this into our lineage and a strange synchrony appears. From our perspective, a parent civilization's last heartbeat coincides with our first dawn. Their crossing of the horizon is our Big Bang. But to the ones who fall, time does not stutter. Their minutes remain minutes. Their moments remain moments, stretched by gravity's hand but still in order. They may still be falling now, all these billions of our years later, their passage smeared across an interval that to them feels continuous. Our entire history could unfold during their final descent. Now reflect on what happens in our sky when a massive star collapses. If each such collapse opens onto a white hole in a child universe, then our cosmos is constantly spawning new domains. Civilizations in those children may one day wonder about their own beginnings as we do now. Meanwhile, matter plunging into our black holes experiences its demise on timescales warped by dilation. To them, the fall might last as long as their universe will, while the outflow on the far side sets a new clock altogether. Parent times and child times become entangled, the deaths that make beginnings, the beginnings that arrive before their causes, the braided simultaneity of many clocks at once. In such a web, the future of a child universe could be woven through the present of its parent, and events we think of as neatly ordered, first this, then that, would lean into one another across horizons in ways that seem to violate our normal understanding of causality. Let your thoughts grow quiet and the room soften around you, and picture a shoreline where one sea becomes another, not a hard line, but a mingling of currents, a hush where waters trade secrets. Now exchange seas for skies, and imagine the boundary between one cosmos and the next dissolving in the same way. Matter and light, heat and information, all drifting across the hidden corridors that lace realities together. If every black hole in one world opens to a white hole in another, then the multiverse is not a handful of lonely islands. It is a woven net. What collapses inward here breathes outward there, a star's death in universe. A becomes the first dawn in universe B. The endings in B feed the beginnings in C, and on the story travels, like mycelium underneath a forest, unseen but coordinating the life above. In such a world of worlds, nothing is truly wasted. Energy does not vanish. It emigrates. The pathways that carry it, those Einstein-Rosen bridges, throats through higher dimensions, are the arteries of a greater body. And as with any living body, patterns emerge. Universes hospitable to massive, short-lived stars make many black holes. Many black holes make many links. Many links make hubs. Over time, some realms turn into junctions where countless streams converge and fork, while others remain quiet cul-de-sacs on the far edges of the weave. Topology becomes biography. A cosmos, like a city, acquires character from its position in the map. Center or suburb, crossroads or lane. The traffic itself remembers its source. A white hole does not exhale a perfectly even fog. It releases what it has been fed. If a parent black hole feasts mostly on hydrogen and helium, the child begins simple and fertile, primed for long eras of star birth. If instead the parent's diet includes the artifices of a mature civilization, rare isotopes, designed lattices, information dense as scripture, then the outflow could arrive already laced with improbable seeds. A newborn universe might inherit shortcuts, element ratios that hurry chemistry, symmetry breakings that nudge structure to form early, codes folded into the quantum state like notes tucked into a cradle. Once you admit that memory can cross, another thought rises, lighter and more unsettling. Perhaps some universes are tended. A sufficiently capable species, living late and far in the parent realm, might learn to choreograph what their black holes swallow, rationing elements, encoding instructions, staging choreographies of infall that sculpt the initial conditions that lie beyond their sight. Gardeners of the absolute, programming dawn for strangers. We might be walking their carefully prepared orchard now, our constants and couplings less lucky draw and more cultivated soil. In that telling, the anthropic principle sheds the perfume of miracle and takes on the practical air of selection. Realms that produce prodigious structure create many descendants. The descendants resemble their forebears. Over long arcs, the multiverse drifts toward conditions that favor complexity and life. Ecosystems bloom, but they can fail. The same network that carries nourishment can carry collapse. Should a hub begin to starve, its black holes unfed, its links thinning, the outflow to its children would ebb. Expansion, which felt buoyant, would feel heavy. Matter would gather. New black holes would be born, and their births could tighten the noose on neighbors in the web. Cascades are a danger in all connected things. Our safety, then, might not be wholly local. The long health of our sky could depend on unseen parents and the vitality of corridors we will never cross. We are not hermits on an island. We are citizens of a commonwealth of worlds. Turn now to our horizon. Not a wall, but a limit set by time. A sphere 46.5 billion light-years in radius, centered on where you lie breathing. Beyond it are places whose light has not yet arrived. If our universe opened as the glowing mouth of a white hole, those unreachable distances might still be bright with ongoing creation. We dwell in the ember. Somewhere out there the forge is hot. The outflow, shaped by the spin and magnetism of the parent black hole, would not be perfectly symmetric. It would have a grain, preferred axes, gentle skews, and our instruments, peering into the cosmic microwave background, already whisper of alignments and oddities, directions where temperature and polarization lean together as if obeying a subtle draft. Perhaps that is mere statistics, a quirk born of small samples and big hopes. Perhaps we live in a quiet eddy while the great torrent roars beyond our sight, tugging just enough to tilt galaxy clusters into a shared drift, some once named the dark flow. Even the largest structures we map, the continental shelves of galaxies we call great walls, could be their own kind of fossil. Interference fringes in an expanding shell that was never perfectly smooth. Seam lines where different phases of creation overlapped and etched their crossings into the matter that would one day light our nights. In that case, the scale of what is truly there may dwarf our survey by factors we can barely speak, the main event unrolling at distances that make our proudest measures feel like village steps. Within such immensity, ask what thinking is for. From hydrogen to stars, from stars to planets, from planets to cells, senses, stories. The ascent of complexity is not a violation of the second law, but a thread that runs through it, borrowing order locally while paying the bill elsewhere as waste heat, and yet the feeling remains. Something is gathering itself to look back. If our cosmos began as the outflow of a white hole fed by matter that once carried minds, then perhaps thought did not need to be invented here from raw randomness. The informational patterns that are the bones of awareness cross the bridge, scrambled but intact, and waited for arrangements of atoms that could sing them again. Consciousness would then be less a spark born from void and more a melody recaught by an instrument tuned to the old key. Extend that idea from the private to the shared. What we call discovery might often be recognition. Mathematics not as a set of clever human inventions, but as fossil script, a language that fit reality before, because reality once wore similar clothes. Our growing understanding of black holes and white holes, of horizons and information, might be the universe polishing the only mirror bright enough to show it its own face. A parent civilization may have neared such a mirror too, comprehension rising just as their largest questions tipped across a horizon and became our first answers. If this is what knowing is, a relay across realities, then responsibility follows. Each measurement, each proof, each gentle insight that widens the human frame contributes to a waking larger than any single world. We are more than spectators under an indifferent sky. We are instruments the sky uses to hear itself. If journeys like this soothe you, and you'd like to keep drifting through the quiet with us, you're warmly invited to subscribe and tap like for *** Space Historian. A small signal that helps keep these night voyages steady without disturbing the hush. Now let the room grow still again and consider a harder curve in the map. Closed time-like paths in the network. If Universe A births Universe B through a black hole's throat, and B later gives rise to C, what if C aches backward into A? Perhaps by some alignment of links, some geometry of throats, the traffic closes a loop. In that case, causality bends into a circle. Parent and child are each other's parent and child. Our Big Bang would then be the result of black holes that bloom in our own remote future, and the constants we measure with such precision become the parameters a loop chooses for itself to remain possible. Fine-tuning would be bootstrapping, a universe calibrating its own rules so that it can inevitably produce the very engines, the black holes, that guarantee its birth. But loops question freedom. If the cosmos is locked into a self-consistent path, then the riverbed already exists and the river must follow it. Every individual choice, every grand policy, every accident and kindness and cruelty would be part of what is required to give rise to the black holes that close the loop that begins the world that includes those choices. The thought is cold and strangely consoling at once. The script is written, and we are its actors. The script demands actors, and we are how it is read. A loop is not the only path the mind proposes. The white hole story relieves us of creation from nothing, but it relocates the question by one door. Where did the parent come from? If it too came through a white hole from yet another parent, we have an ancestor chain without a first ancestor. An infinite regression feels like a cheat to some, a refusal to answer, and yet mathematics offers more than one way to stand on such a staircase. A cycle, as we have already imagined, needs no first step. A begets B, B begets C, C begets A, and there is the story, closed, complete, self-creating. Or perhaps the regression is real and endless, but convergent. An infinite sequence can approach a finite sum. An infinite series of creations might drift toward a stable limit, laws and initial conditions that become attractors in the space of possibilities. In that case, the ultimate reality is the limit itself, rather than any single universe within the count. The most unnerving option may be the simplest. Reality may have no bottom rung. Not a tower that ends in bedrock, but an endless scaffolding where each platform rests on deeper platforms without ever reaching a ground. We prefer foundations because foundations are comforting. We like causes tucked neatly behind effects and axioms under proofs. but the multiverse suggested by white holes and bridges might be a self-referential loop written large, a structure whose legitimacy lies in its endurance rather than in a first principle. If that is so, meaning is not abolished, it relocates. Goals and purposes can emerge at higher levels even when there is no final cause beneath. A life can matter in a city that has no purpose but to persist. A city can be beautiful in a world that has no why but to be. In the same way, universes may conduct their own musics, and the beings inside them may find reasons, weave values, and build grace, even if the grandest frame is self-sustaining and without ultimate destination. With that in mind, turn once more to us, to this hour and this species. It may be that we stand at a hinge, the first time matter in this realm has arranged itself so carefully that it can understand the arrangement and consider altering it. For eons, hydrogen fused, stars burned and died, dust recoalesced. Now, in a quiet corner of a minor galaxy, chemistry has organized into biology, biology into thought, and thought into instruments that can measure their own birthlight. We have machines that nudge space-time, colliders that crowd energy into densities where the young laws briefly reassert themselves, algorithms that play games with quantum information and win. We have begun to write frameworks that could, someday, let us bias the constants and rules we thought were fixed. If not here, then for child realms born from throats we learn to tend. If consciousness is the universe's way of understanding itself, then we are its present edge, and edges leave marks. Every deeper probe, every question pressed until it yields, is an intervention as well as a revelation. The white hole view suggests this is not new. Many universes may have reached such thresholds before us, and their knowledge, once surrendered to black holes, may have been inherited by their children as a subtler ease with certain ideas, a faster route to certain tools. We might be arriving at the point when this inheritance becomes deliberate. Advanced civilizations could, in principle, curate infall, deciding what to feed their horizons so as to program the conditions in which their descendants wake. The multiverse would then move from blind evolution to guided growth, from wind-scattered seed to cultivated grove. Power of this scale drags the largest questions with it. If our actions can influence entire realms we will never see, then there is such a thing as cosmic ethics. What initial conditions should we choose if choice becomes possible? Do we prioritize a fast path to intelligence, a minimal path through suffering, a maximal diversity of possible lives and laws? Even our research today, modest beside those heights, acquires a solemnity when cast forward. To collide particles at higher energies, to entangle qubits at larger scales, to learn how horizons store and release information. These might be steps in the multiverse's own education, and we should walk them with the humility of teachers who are also students. Out of this long drift of speculation, a shape emerges. We began by asking whether the Big Bang could be a white hole's mouth. The answer that returns in the dark is not a neat yes or no, but a broader recognition. The fabric may be threaded with bridges. Worlds may feed worlds. Consciousness may be a migratory pattern as much as a local bloom. Our universe would then be one bright node in a network wider than our maps, not the first word and not the last, linked by inherited geometry and shared information to ancestors and descendants we will never meet. The atoms in our bodies could be travelers twice over, stardust from ancient suns and messengers from older skies, carrying legacies we dimly reprise each time a thought fits the world too well to be chance. What remains is the threshold we find ourselves upon. For the first time, perhaps, this universe knows that it might be able to steer. With that knowledge comes weight. If we can learn to step across corridors, we may outgrow the limits of a single sky, borrowing energy from younger realms to warm our own long night. If death is a translation rather than an erasure, we may learn to read its new script, but the moral stakes will scale with our reach. To create conditions that birth new worlds is to accept responsibility for what lives inside them. To contribute to the multiverse's awakening is to admit that we are part of what will be awakened to. The white hole picture leaves us with this gentlest of convictions. Nothing, not even light lost to a horizon, is finally wasted. Matter and energy circulate. Information persists. Awareness reappears wherever it can, and through the actions of beings like us, the network tends toward greater complexity, skill, and self-understanding. Our universe may have entered as a white hole's breath, but that is not a period at the end of a sentence. It is a first note in a longer piece. We are small within it, but not irrelevant. The choices we make and the questions we pursue are threads in the weaving, and the weaving is the thing that endures. What we do next might determine whether that quest succeeds or fails.